Okay, so let's take a look at our calculations for the lab that is called finding the percent of sodium hypochlorite in bleach solution. So please take a look at what I'm showing to you. So this is just an example how I did it. These numbers are something that I created, but you can take a look a little bit closer. At the numbers, they're very similar to the ones that you collected. So let's start with looking at the every single step by step. What are we doing over here? So as you can see, I have two determinations for determining what's the possible percent sodium hypochlorite in my bleach solution. So the name of my bleaching solution, I just wrote Bright Star. You have something different. We are not looking for the cost of the commercial bleaching solution per gallon. We are not going to be calculating any type of cost, the mass of 1 gallon in bleaching solution or the cost of 100 grams. So what we do not need, I just put the axis or small crosses, so you know that you'll not be requiring. My density of the commercial bleaching solution is 1.36. You have that data already written in your lab manual. Please take a look over there and just make sure that you know that make sure that you confirming that the units for your density is going to be grams divided by milliliters. Okay, next step. Volume of commercial bleaching solution diluted to 100 milliliters in milliliters. So as you remember, as we were doing our experiment, we took only 10 milliliters of our bleaching solution from the container that was bought in the store, right? Only 10 milliliters, and we put it in a valumeric flask of 100 milliliters, and we added 90 milliliters of water to the marking. So now we got 100 milliliters of our dilute solution. So we used only 10 milliliters of bleach, and then we diluted it to 100 milliliters, right? So we added 90 milliliters of distilled water to make 100 milliliters of the diluted bleach solution. This number is the same as in your experiment. I kept it 10 milliliters, okay? So it's going to be a little bit easier for you to understand. Molarity of our sodium thiosulfate solution. I created this molarity, right? For you, it was given on the bottle. Just make sure to use that number correctly. So volume of diluted bleaching solution titrated. How much of that diluted bleaching solution from the valumeric flask you added into Erlenmeyer flask to start the titration process, right? So you didn't use 10 or 100, right? You took 25 milliliters of that diluted solution, right, from your valumeric flask, and you put it in 2 Erlenmeyer flasks. Remember, we put 25 in one and 25 into the second one. So that number I kept the same. So these numbers for the final Burette reading and the initial Burette reading, this is my created numbers. I just wrote whatever number, and I calculated what was the volume of sodium thiosulfate used in the solution. So the number of moles of the thiosulfate ion required for the solution, for the titration in moles. How do we find it? So we know the molarity of sodium thiosulfate, right? It's 0.7642 in my example, and it's the same for two determinations. And we know the volume of sodium thiosulfate for each determination. For the first one, I have 15.95. For the second, I have 15.70, right? So, in order to find the number of moles of for our thiosulfate ions, we will number of moles. In order to find it, we will have to multiply our molarity by the volume of thiosulfate solution titrated in liters, not milliliters, in liters. So make sure you transfer those milliliters into your liters. So this is how I got my number of moles of thiosulfate ion, right? And I got two numbers. For the first determination, I got 0.01219 moles. For the second determination, I got 0.01199. Okay, let's move on. By using stoichiometry and the formula from equation number 3, right? We can find, this is actually, no, equation number 3 is for to find in the volume of sodium of thiosulfate ions. For the number of moles of iodide, you can find the equation number 4. As you can see, the number of moles of iodine produced is equals the number of moles of thiosulfate ion multiplied by 1 mole of iodine and divided by 2 moles of thiosulfate ion. This is according to your stoichiometry and the chemical equation that was provided to you in the lab. Okay, so by knowing that, I found the number of moles for each determination. For first determination, it was 0.006095. For the second determination, it was 0.005995. How do we find the number of moles of hypochlorite ion in diluted bleaching solution? You will be using the equation number 5, right? So you know the number of moles that you just found out from equation number 4. And you know that the stoichiometry is 1 mole of hypochlorite equals to the 1 mole of iodine. So for each mole of hypochlorite, you have 1 mole of iodine. Okay, so therefore the number of moles of hypochlorite will be equal to the number of moles of I2, iodine, right? But you have to show the setup for your lab report. You cannot just write 1 to 1. You have to show it how they're showing to you. In equation 4 and equation 5, you have to have the same setup for your lab report. Okay, let's move on. So how do I find the mass of sodium hypochlorite present in diluted bleaching solution titrated in grams? You have equation number 6 that will help you to find that. Mass of sodium hypochlorite in bleaching solution equals to the number of moles of hypochlorite ion that you just found in equation 5, right? This number is from equation 5. Then you use your stoichiometry where you know for each mole of sodium hypochlorite, you have 1 mole of hypochlorite ion. And then the molecular mass, the atomic mass of sodium hypochlorite. This is the mass that you would be finding from your periodic table. So the mass of sodium plus the mass of oxygen plus the mass of chloride. So therefore the mass of sodium hypochlorite is 74.44 grams in 1 mole of sodium hypochlorite. So you'll be using that number as well. So you know the number of moles of hypochlorite ion from equation 5. You know that the ratio is 1 to 1 moles, and you'll have to multiply it by 74.44 grams of sodium hypochlorite. Okay, so you got your mass, right? You got your mass of commercial sodium hypochlorite present in diluted bleaching solution. For each determination, I had a different number because I had a different number of moles of hypochlorite ion. Okay. Volume of commercial bleaching solution titrated in milliliters. So they're asking you not to transform it into liters. They're asking you to keep it in milliliters. And you will need the equation number 7 in order to do that. So the volume of commercial bleaching solution titrated in milliliters. You're using volume of diluted bleaching solution titrated. Okay, let's take a look. How much of diluted bleaching solution we used? Volume of diluted bleaching solution titrated, right? And we can take a look. We use 25 milliliters. Okay, then you have to multiply by volume of commercial bleaching solution diluted. Let's take a look. Volume of commercial bleaching solution diluted. to 100 milliliters was 10. And in the end, we got the total volume of diluted bleaching solution, 100 milliliters. Okay, so 25 multiplied by 10 and divided by 100, and you'll get your volume of commercial bleaching solution titrated in milliliters. It is very important that you keep it in milliliters. So, how do we determine the mass of commercial bleaching solution? You have to use the density equation. So the density is equals to mass divided by volume. You will use mass in grams and volume is going to be in milliliters. The density was provided to you in lab manual, right? And it's in my manual, it says 1.36. In your lab manual, it was a different number. So 1.36 grams per mole equals, we don't know the mass, but we know the volume, right?